Good morning, Casey.
Yo, how are you, Mark?
I'm doing pretty good. Ooh. How are you?
Fighting the good fight against RGW multi-site bugs.
I actually had someone mention that last night. I had forgotten about it. I was at this like Minneapolis Ceph meetup, and they had mentioned that there was some issue with distributed replication and OMAP data not being properly replicated or something and like silently failing.
Huh, that doesn't ring a bell.
Okay. Yeah, I think it was like RGW multi-site type stuff, I guess. But anyway, that was all I had really heard about as far as technical details go.
Yeah, I don't think that there's anything in OMAP that we really replicate between clusters.
Yeah, I not an area I'm very familiar with, so no idea.
All right, well, I'll keep an eye out for bug reports.
All right. Hopefully we get Sage. The core meeting was going over a little bit. Give him another minute or two. Hey Casey, in the meantime, how's Beast going?
I mean, it seems to be stable. Um, it's let's see, it was marked not experimental in Mimic, so we haven't heard a lot of feedback. Hopefully, that means no bugs. There's a lot of follow-up work to actually take advantage of the asynchrony in RGW. That work is progressing, but kind of slowly. But I'm hoping that we can get kind of the important pieces in for Nautilus.
Is that going to be like made default, or is it made default now? I actually don't know.
No, it's not. I guess I hadn't thought about
Okay.
that part.
Yeah, I was just curious if like there was a plan for doing that or not.
Eventually, yeah, once we start seeing a lot of wins from Boost Asio and being able to cut down the number of threads, we definitely want to phase out Civet Web.
Yeah, yeah, cool. I was thinking I should probably try to start moving over to that for any. I don't do RGW testing that often, but um, I've been doing some for the memory auto tuning work as just kind of like another aspect of it, since that creates generally tends to create much heavier OMAP workloads. So maybe I should switch over to Beast for that now.
Yeah, cool.
Is it just like as easy as swapping out the CivicWeb like RGW backend or whatever it is option?
Yeah, the RGW front ends config.
Or
You
front end,
just
yeah,
say
yeah.
Beast instead of Civet Web.
Okay, neat.
There's docs for like the extra options and stuff, but basically exactly the same.
All right, good deal. All right, let's see if I just ping Sage on IRC because I saw he's responding to stuff. All right. Well, haven't heard from Sage, so I'll just get us started. Let's see. All right. Not too much new stuff for pull requests this week. Igor had a modification for the auto tuning stuff. I think it's just specific to on startup, making it a little bit more aggressive about tuning immediately. I need to look at that. It also changes the frequency of tuning, which may be a good idea, but it may have effects as well that aren't good. So at the very least, we need to test that because that will affect more things than just startup time. Um, let's see, there were two that closed. This one from Kifu, I think, for optimizing stack string stream. And then also one here for from Sage for the NUMA affinity and pinning stuff. Sage, I was just starting to go through the pull requests. Do you want to talk about your NUMA stuff at all? You're silent.
There. It merged. There's a new command that lets you easily show the NUMA node for the storage and the network for each OSD, and you can easily pin it with the Ceph config set. So that's mostly it. It also tries to pin itself if it happens to notice that the network and the storage are on the same node, but I'm not sure how many real machines that actually applies to, so who knows if that's really going to be useful or not. We'll find out as people deploy Nautilus, I think. What else is new?
This libRed multiple cache write back threads actually looks kind of interesting. He's getting numbers really close to having cache disabled.
Oh, that's cool. And who is Liu Chow? Anyway, cool. Looks like Jason's already reviewing. Okay. I don't know if any of this, none of this other stuff really looks worth commenting on right now. The VLAs is just a cleanup. Cryptos change, what's going on there?
Yeah, it was silent for a long time, and then it looks like Peter maybe pushed something. I didn't look at what it was, but
looks like it's still. Oh, we force pushed.
Yeah, I didn't pay too close of attention to it, but
yeah, okay.
I guess I can't look at what it is unless I still have a copy of it from before.
Yep. All right. I don't know. That's really all I have. I'm mostly focusing on the messenger juice stuff for Nautilus. Not reading a lot.
Cool. All right. The only thing I was thinking for discussion topics that I was gonna bring up was that I heard a rumor that the C-Star OSD is booting. Is that right?
True.
Kifu erratic.
Yep, it's leaving.
Cool. Does it do anything?
Well,
it is just added to the OSD map. That's all. And keep it to be self visible by monitor.
Progress. Cool.
So what does that
Is that
mean
what-
in terms of like? Oh, go ahead, Sage.
Is that what that pull request was that you pointed to?
Yes, that's the one I was begging for a reviewer.
Right. I mean, I can just click review if you want to just merge it. I actually don't
Yeah.
feel qualified to review any of it.
Yeah.
Okay. I'll just click review.
Kifu, I'm aware I owe you a review. Doing that right now basically
Okay,
looks
that would be great.
looks fine. There are some very very small minor things we can address later after the video. Things like consuming messengers and embedding aggregating them inside OSD.
Okay, great. I could address them tomorrow because my goal is to get it merged by the end of this week.
Okay.
Thank you.
Sounds good.
Uh,
Cool. Okay.
Kifu and Radek. So what's next? Like how close are we to having like a mem store thing in there that we can test?
Next thing is we are being able to return random bits for random reader requests sent from a reader client. And the next thing is to get the read path correct and reply with some payload that the client is asking for. I mean, put it in another way to connect to a customized version of a memory store, which serves the read and write request.
Sure. That's exciting.
Yeah.
All right. Well, I don't have
All right.
anything else. Anyone else want to chime in or bring up something?
Don't have
SPDK
anything.
integration in long term.
Mm-hmm.
Well, I guess that from SPDK we will want to grab the low-level NVMe driver, maybe not the NVMe over Fabric, which looks like network NVMe, which should be the task of RunSD. Networking as storage.
So Radek, my suggestion would be to actually get the BDEV driver. If you can take a look at the BDEV layer, right?
Yep,
So instead of using, yeah, so instead of using the NVMe, NVMe driver directly, you can use the BDEV. That'll actually give us a lot of flexibility.
I see. Even supporting RBD inside.
Correct. So underneath BDEV, you can actually have, I mean, not RBD inside, but you can have NVMe or fabrics. You can hide under there like an LVOL kind of layer, like logical
Sure.
LVM kind of layer.
If I may.
Yeah.
Is BDEV dependent on the SPDK event framework?
No, it is not.
No. Okay.
It is independent. It's just an abstraction layer that was created, just a level above, so that we. So
I see. Relatively thin.
Yeah. So I'm actually trying to redo the BlueStore backend, but that we have for NVMe, and I chatted with Kifu just a little bit about that, but I'm trying to redo that with BDEV right now, so I can actually send you that patch or add you as a reviewer just let you know what I'm talking about. So yeah. But it's essentially it's a block dev abstraction, which basically hides like implementation of whether it's of the device itself, right? Whether it's a network device or a local device or a logical volume kind of implementation. Actually, we are actually even building a caching, like with cache kind of a block device. As well. So yeah, I mean, a whole bunch of things can be abstracted out with BDEV with minimal overhead. So
Tusha, speaking of BDEV, I think the ProgFS is more attracting because we can even it can even support the facility required by RocksDB, right?
Yes, yes, you can do that. Yeah, absolutely. Yeah.
So we can even build BlueStore over RocksDB, and which we will build on top of ProgFS.
What
But
FS?
we need BlobFS, I guess.
BlockFS?
I think
BlobFS.
BlobFS.
Blob,
Okay,
Yeah.
got it. Yeah.
yeah, it's just a non-POSIX, file system. It's just a block allocator. Really.
Okay.
Yeah, it's a pretty bare bones thing. That I think, Sage, I think we had talked about it like initially two and a half years ago or something.
Yeah.
It was right when BlueStore was coming about. Yeah, BlueFS was coming about. Yeah, and by the way, Sage, actually I told you last year that CAS was going to go open source. I worked really hard this year to convince the management. It is in fact open source now. We actually open source just last month, and so
Cool.
I mean, again, this is kind of on the side, but just because I uttered the word CAS, I just wanted to put it out there that it's actually open source, and we can use it like if we need to in some shape or form. So
Cool.
yeah.
Cool. Okay.
Yeah. but otherwise, actually, I like if you're done talking with the star stuff, I just want to acknowledge that. So Sage, I think your patches for the NUMA stuff will be extremely helpful because we throughout the like when we have been like putting together these reference architectures with our field guides and so on. The NUMA affinity was always kind of
super nice.
hand wired. Yeah, it's difficult to kind of. So so Orlando is actually on the call right now. I mean, he knows what a pain it is to actually use NUMA control and place the OSTs strategically. So it's really useful. And so we actually have some nodes where we can do sort of maybe at least 2 NVMEs per NUMA node. Kind of balanced. We'll see if we can give this a try and bring some data back for discussion. Yeah.
Okay. I had a question.
Sure.
My intuition was that if the way that you would ideally want to structure your hardware is that if you had 2 NUMA nodes, you would have like 2 NVMEs on each NUMA node, and then 1 NIC on each NUMA node, and you would ideally have the OSD on NUMA node 0 use the NIC attached to NUMA node 0, and the ones on 1 use the NIC on 1. Is that actually the case? Is that how it works? So far, like all my boxes have like the NVMEs are on NUMA node 1, and the network card is on NUMA node 0. So there's like no. I'm just wondering
so actually,
how does that work?
Yeah, so I would say that's how it should work, but actually all the Dell and HP boxes that we use, typically they're not built for these high density storage kind of applications. So they always to save and also to save cost, they always end up putting a by 16 expander and get 4 NVMEs that way on one side. So they just don't bring out enough PCIe out of the processor, even if it's available. Like for example, the Skylake processors have 48 PCIe lanes each. So you have 96 lanes, but if you look at CPU 0, typically nobody brings out more than I don't know, maybe half the lanes. So the only box that's out there, actually, I was working with Quanta to fix this problem, and I did a talk also at a Ceph Day on this. So Quanta is the only vendor that has a system which has a perfectly balanced 12 NVMe system in 1U. With 6 NVMEs on each node, and they have a by 16 slot on each node as well, so where you can place up to 100 gig NIC. So I'm trying to get some of those systems, but we do have some internal like initial validation kind of systems, which have the ability so that we can cable stuff around and get the perfectly balanced. So in production, it's kind of hard to find these systems. So for now, we'll see if we can help assess the performance. But in the past, actually, there are 2 data points I can actually share. So in the past, like when we had done some testing with Preluminous, I remember, and Orlando can keep me honest here, but I think the benefit to going to fully NUMA balanced was about 10 to 15%. But then we did some recent analysis where we saw going from single socket to dual socket. I mean, again, sort of NUMA balance, we were able to extract only 25% more IOPS. So we can do more, like once we see how your patch does. But we're not able to scale to 2 sockets yet. It's only 25% more. So yeah.
Okay. I guess the
Sage.
sort of the question I had, follow-on question I had was, assuming that you do have like all the NICs on node 0 and some of the NVMEs are in node 1, is it better to pin the OSD to closer to the storage or closer to the network, or neither, and just let the kernel sort it out?
Yeah, I don't know. Orlando, can you?
We don't know.
Do you want to take that one? Orlando, are you here?
Sorry, guys, I was muted. What was the question again?
If you have an unbalanced system where the network is on one node and the NVMEs are on a different node, is it better to pin the OSD closer to the network or closer to the storage, or neither, and just let the?
Yeah, that's a good. Actually, I don't know which one is better. Usually, we pin it to the NVMe device, so whatever that's located on. But yeah, and then recently we just let the scheduler figure that out.
Okay. I guess it'll be a lot easier to play with that with the new code because you can super easily move the.
Yeah. I think that the patch is really helpful because we should be able to experiment a little bit more in this area for sure. Because maybe we almost we only kind of went to the two sides, let the scheduler figure it out, or kind of completely partition the two, and we literally had 2 subnets essentially on two sockets, literally treated those. But we haven't looked at the hybrid really, where should the OSTs be. We have just been running OSTs. I mean, we just been using all cores, so didn't really pin it to one side, to be honest with you. So
yeah, okay.
Hey Sage.
Yeah.
I suspect that just pinning it somewhere is the real benefit, rather than having the kernel try to move things around, right? Yeah. That's really what you pay for, is if you're moving it back and forth because it's thinking that it's gonna do something clever that's not really clever.
Yeah. So the other part that's in that pull request is that if there are multiple NUMA nodes and the storage is on one particular NUMA node, and you configure the OSDs such that you specify the public network, then when it searches the local machine for which IP to bind to for the network, it'll try to choose an IP that's on a NIC that's on the same node as the storage. And my expectation was that then when you have a NIC on both NUMA nodes, you could configure them with different IPs but on the same network, and then the OSDs would bind to whichever one was on the right NUMA node, and so they'd end up on the right NIC. I don't know how, again, since these systems, there aren't really any balanced systems out there, or very many of them, just the Quanta one. I guess that isn't really going to help anyone yet, but I'm hoping that eventually it will. And I think that I have a feeling what we should do is basically sort of get rid of all the old guidance around creating a front side network and a back side network, roll that out, and instead suggest that people have all their NICs on the same network. And hopefully eventually then stuff will be as smart as possible about sort of auto balancing across the.
So is that common though, to see multiple IPs on the same node?
I don't know. Probably not. But if you have two, I think probably what people do is they would bond them. I think so. The old guidance was have one NIC on the front side network, one NIC on the back side network. And then sort of the newer guidance is more, although that documentation doesn't say this, but the newer guidance is really to bond them. And so you have some redundancy. If one NIC fails, then it'll use the other one and use some bonding protocol with your NIC. But I have a feeling that for high performance situations, the bonding isn't really going to help because it's basically, especially if the NICs are on 2 different NUMA nodes, then you're like, I'm assuming that it's not going to be smart. It's just going to slow it down instead of speeding it up. And so I'm wondering if, yeah.
A lot of the problems that we've run into with partners in their labs when we try to do testing is due to bonding. They have some like messed up bonding setup that breaks in irritating ways.
Yeah, actually the only challenge I see is with the network config. Like if you the same, usually the IP address belongs to, so usually it doesn't allow the same subnet. Two NICs on the same subnet may not work because the routing, the way the kernel routing is set up, you will, like, all your packets will be forwarded to essentially the first, the interface that appears in the first routing entry. So that's maybe an issue, but yeah.
My understanding is that if the socket is, if you bind the socket, then you can control which network it goes out. And in fact, there's something in Ceph where even on outgoing client connections, you can bind it to a particular IP to force it to go out on a particular network. I assume that's, I'm not certain if that's the case, but that's the case for transmit, yes. I mean, for send. For receive is where I was, we may have to do some IP routing, IP policy routing magic to do that. It is possible to do. Then but yeah, on the receive it won't be automatic, and there'll be some additional. But yeah, it's possible to do work around that for sure. Yeah. It would be interesting to try.
One of the problems from a cost. Sorry. I think one of the problems from a.
All I was going to say, sorry, Mark. We need to do random and come back off, but so I was just commenting on the issue with multiple NIC ports on the same subnet, with different addresses. If you do that, you've got to be careful about ARP, because what can happen is it can start sending traffic to the other one. It's something we've run into before, and there's a way to fix it, which is to set ARP filter to 1 so that it will actually go to the interface that you want it to go to. I'll try to send a link about this, but I think it's a fairly well. Has anybody else heard of this? I mean, it's been around for years.
Yeah. The ARP filter and the gratuitous ARP, those two settings need to play with. And for L3, actually, I was describing more of the challenge with layer 3, because when the packet is received for that subnet, it's the route lookup is only going to happen on the subnet address, right? It's not the specific IP address, so it may not be delivered to the right interface, because the kernel routing entry tells it to go to, let's say, 80, but the IP address actually belongs to 81, right? So there may be some ping pong there, but with IP policy routing, you can actually set some rules, and I can actually try some examples and send across. But yeah, if you can share that link that you're talking about, that'll be great as well. Yeah.
Sage, one thing I'm a little worried about with the idea of having a separate network card on each NUMA node is that it's so much cheaper to buy a single NIC that has like two ports on it than it is to buy two separate NICs that have one port. But if you're talking about like dual 2-port 10 gig or 25 gig, depending on how much you need, maybe we could still kind of justify it.
Yeah, actually, Mark, what we see is, the cost of the NIC in these dense NVMe systems is going to be, so small, like as a percentage of the total, because most of the cost is actually in NVMe's likely. So that's kind of what we've seen, and so like we just did a big exercise with OVH, and it's likely that they, we did some TCO analysis basically on these nodes. So I would say the NIC cost is probably, less than 5%, like 2 or 3% of the total cost. So yeah, so we may be okay, I think, for that. Yeah.
Cool.
I wonder, Tushar, if separately we're talking about the inserter refresh, if those quantitative machines might be a possibility, if it'd be possible to get a balanced set of boxes. That might be.
Yeah. So I'm trying to see if we can get basically the latest systems that have the right expanders. So the Skylake systems, the white boxes, the Intel white boxes, they come with different expander options. So we have figured out how to actually configure those NUMA balanced. We may not be able to get like everything NUMA balanced, but at least the NVMEs we can get NUMA balanced. So I'll say we'll try to make it as close to close to that config as possible. And if I'm also trying to get some quotes from Quanta to see if they can give us systems with the Intel discount. If we can get those QCT systems that are 1U and perfectly balanced, I mean that would be actually the ideal case. I'll see what I can do. I'm just being asked because we actually lost the opportunity for the budget last quarter. I'm just trying to reassess things this quarter to see how quickly we can get budget. And so the idea was actually to announce something like this at Ceph that we have a new cluster, community cluster, and just make some announcement. Our marketing is definitely trying to get this done this quarter so that we have some time to get it installed potentially. So
cool. Okay.
Yeah.
This machine is not totally balanced. It's like 6 and 4, but it's maybe better than some. I remember seeing this from one of the super micro guys.
Yeah, the 1028, right? Yeah. So the 1028. 1029 is the Skylake. Yeah, that's right. So that one is actually 6.4.
Yep.
But but you don't have the by 16. You don't have the NIC like balanced NIC capability on both nodes typically on those servers. The way they bring it out. But that's close actually. Even if I can get 1029s, we can do 4 NVMEs each node, and that's how we did it actually last time. I know, Orlando, I think that was 1028 or 1029, right? That we used for the balance config.
Yeah, 1028.
Yeah, that was the Broadwell. That's right. Okay. Yeah. Okay. Yeah. So I'll look at those options as well, Mark. Yeah. Really. So.
Cool. Okay.
Yeah.
All right. Anything else? All right. Get back to the Nautilus stuff.
Yeah.
Okay. All right.
All right. Thanks,
See you later, guys.
Bye.
Thanks, everyone. Take care.
Bye. Bye.
Bye-bye.
See you next week. Bye.